Students, now we are discussing one more important ESET question. This question, see here, in 2014, 15, 16, 18, 20 and 21 last year. See, number of times in our modern physics this top question is coming. What is our topic name? Einstein Equation of photoelectric field. So student, first I will explain the concept of this topic, then we are solving this question. See here, Einstein Equation of photoelectric field or photoelectric effect. Here light, I am considering light is a wave. See here students, I am considering light is a wave. This light wave is a stream of particles. This light wave is a stream of particles of electromagnetic energy, and these particles of this light are known as photons. So student, light is a wave. Here the light wave consists a stream of particles of electromagnetic energy. ఆ particles మనం ఇక్కడ ఏమంటున్నాం? Photons. See here. Now I am considering a metal. This is a metal. See here student, concept very important. This is a metal. What is this? This is a metal. This is light. So when a light is incident on a metal surface, this is metal surface. When a light wave is incident on a metal surface, so metal means what here? Conductor, it consists of electrons. So when a light is incident on a metal, then the charged particles here electrons, the electrons are emitted. The electrons are emitted from this metal. See here students. So when a light is incident on a metal surface, then the electrons will be emitted from the metal. The emitted electrons are known as photoelectrons. Electrons ఏమంటున్నారు ఇక్కడ? Photoelectrons. The emitted electrons are known as photoelectrons, and the phenomena is known as photoelectric effect. Photoelectric effect. See students, here very important, light consists some stream of particles. The stream of particles of electromagnetic energy, the particles are known as photon. So when a light is incident on a metal surface, then electrons will be emitted from the metal. The phenomena is known as what? Photoelectric effect or photoemission. Here I am considering energy. What is E? Energy of incident wave. Energy of incident wave. This energy of incident wave is directly proportional to frequency of incident light. Students, very important point. The energy of incident light is directly proportional to frequency of incident light. Here I am representing frequency symbol small v. E directly proportional to frequency. Then E equals to I am writing E equals to H into V. E equal to H into V. Students, the energy of incident wave is directly proportional to frequency of incident light, and here E equal to H into V. Here student must remember 2 points. What is H? H is Planck's constant. What is H? Here H is Planck's constant. H value you remember, that is 6.625. 6.625 into 10 power minus 34 Joule second. Remember, H equal to 6.625 into 10 power minus 34 Joule second. And here one more important point, energy units. Generally energy units are, generally in physics we are using joules, but here we are using energy units electron volts. Energy units are electron volts. So student, you remember here 2 points, the energy units are joules and electron volts. So relation between electron volt and joules is equals to, I am writing 1 electron volt. 1 electron volt is equals to 1.6 into 10 power minus 19 joules. Sometimes the question is asking energy and answer will be given sometimes in terms of joule and sometimes in electron volts. We require relation. To find energy value in joules as well as electron volts, you must remember the conversion between joules and electron volts. What is that? 1 electron volt equal to 1.6 into 10 power minus 19 joules. So E is what? Energy of incident light. What is V? Frequency of light. And H is Planck's constant. Similarly, from C equal to F lambda, V equal to N lambda, C equal to F lambda. Here I am writing C equal to frequency V into lambda. Then frequency I am writing in terms of wavelength, that is C by lambda. Frequency formula I am writing C by lambda. Then our equation E equal to H into V, that is frequency equation. Now I am writing E equals to H into C by lambda. E equals to what? H into C by lambda. See here student, first energy of incident light is directly proportional to frequency of light, that is V. I am representing small letter V. Then E equal to H into V, where H is Planck's constant. Then after that we writing frequency formula in terms of lambda, that is C by lambda. Here very important point, this E equals to, now I am writing E is equals to 12,400, because H value constant we know that, and C is velocity of light 3 into 10 power 8 meter per second. Therefore E equal to 12,400 by lambda, and energy units here electron volt, and very important point, wavelength lambda is in angstroms. Wavelength lambda is in angstroms, student. And 1 angstrom equals to, you must remember, 1 angstrom equals to 10 power minus 10 meters. 1 angstrom equals to 10 power minus 10 meter. Student, if you remember these 3 formulas, compulsory you will get 1 question from this topic, and conversion is very important. So student, ఇక్కడ మీరు గుర్తుపెట్టుకోవాల్సినవి 2 పాయింట్స్ ఏంటంటే, ఎనర్జీని జౌల్స్ లో గాని అడగవచ్చు, ఎలక్ట్రాన్ వోల్ట్స్ లో గాని అడగవచ్చు. So you must remember the relation between joules and electron volts. 1 electron volt equal to 1.6 into 10 power minus 19 joules. అలాగే వేవ్ లెంత్ ని ఆంగ్స్ట్రామ్స్ లో అడగవచ్చు, మీటర్ లో అడగవచ్చు. So you must remember the relation 1 angstrom equals to 10 power minus 10 meters. So when a light is incident on a metal surface, then the electrons will be emitted from the metal. The emitted electrons are known as photoelectrons, and the phenomena is known as photoelectric effect or photo emission. Now here Einstein explained that. What he explained means, when a light is incident on a metal surface, when a light is incident on a metal surface, so here what is light? Light is a wave that consists of particles of energy. The particles are known as photons. So ఇప్పుడు నేను ఏమంటున్నానంటే, when a photon is incident on a metal surface, so it consists of energy. So some energy is required to emit the electrons. మనం ఎప్పుడైతే లైట్ ని మెటల్ సర్ఫేస్ పైన ఇన్సిడెంట్ చేశామో, when light is incident on a metal surface, that light consists of energy. ఆ ఎనర్జీని ఇక్కడ నేను ఏమంటున్నాను? E. ఆ ఎనర్జీని ఏమంటున్నాను ఇక్కడ? E. So when light is incident on a metal surface, E, in that some energy is required to emit the electron. some energy is required to emit the electron. ఇక్కడ మనము ఇంకొక టాపిక్ కూడా చదువుతాం. The minimum amount of energy required to emit the electron is known as work function. Work function, it is represented by W. So W అంటే ఏంటి? వర్క్ ఫంక్షన్. వర్క్ ఫంక్షన్ అంటే ఏంటి? ద మినిమం అమౌంట్ ఆఫ్ ఎనర్జీ రిక్వైర్డ్ టు ఎమిట్ ద ఎలక్ట్రాన్స్ ఫ్రమ్ ద మెటల్. సో వెన్ లైట్ ఈజ్ ఇన్సిడెంట్ ఆన్ ఎ మెటల్ సర్ఫేస్, సమ్ ఎనర్జీ, ఇన్ దట్ సమ్ ఎనర్జీ ఈజ్ రిక్వైర్డ్ టు ఎమిట్ ద ఎలక్ట్రాన్. దాన్ని నేను ఏమంటున్నానంటే వర్క్ ఫంక్షన్. The remaining energy is given to emitted electrons as kinetic energy. The remaining energy is given to emitted electrons as kinetic energy. అంటే when light is incident on a metal surface, that incident light wave consists some energy. ఆ ఎనర్జీని ఏమంటున్నాను ఇక్కడ E. ఆ ఎనర్జీలో సమ్ ఎనర్జీ ఇస్ రిక్వైర్డ్ టు ఎమిట్ ద ఎలక్ట్రాన్స్. ఆ సమ్ ఎనర్జీ, ఆ మినిమం ఎనర్జీని ఇక్కడ ఏమంటున్నాను W. W మీన్స్ వాట్? వర్క్ ఫంక్షన్. ద రిమైనింగ్ ఎనర్జీ ఈజ్ గివెన్ టు ఎమిటెడ్ ఎలక్ట్రాన్స్ యాజ్ కెనెటిక్ ఎనర్జీ. సో ఫ్రమ్ దిస్ కాన్సెప్ట్ ఐఎమ్ రైటింగ్ E ఇన్సిడెంట్ లైట్ ఎనర్జీ E ఈక్వల్స్ టు వర్క్ ఫంక్షన్ W ప్లస్ కెనెటిక్ ఎనర్జీ. Students, this is Einstein photo equation. Einstein equation. So ఏం చెప్పడతాను? when light is incident on a metal surface, some energy is required to emit the electrons. Some energy I am representing with what? W. What is W here? Work function. The remaining energy is given to emitted electrons as kinetic energy. So E equals to W plus KE. What is E? Energy of incident light. What is W? Work function. And K is what? Kinetic energy. So here I am writing kinetic energy KE equals to E minus W. E minus W. See here. Kinetic energy K equals to E minus W. When energy and work function both are represented in electron volts, then kinetic energy also in electron volts. But generally kinetic energy represented in joules, then you require conversion. 1 electron volt equal to how many joules? 1.6 into 10 power minus 19 joules. So this is Einstein photo equation. So ఏం చెప్పడను? when a light is incident on a metal surface, that light wave consists some energy. That energy here we are representing with E. Now in that energy, some energy is required to emit the electrons. That some energy I am representing with what? W. Work function. The remaining energy is given to emitted electrons as kinetic energy. So E equals to W plus KE. So here kinetic energy equals to E minus W. This equation is known as Einstein equation. Now read this question. On making ultraviolet light of energy 6.2 electron volts is incident on aluminum surface, faster photoelectrons are emitted. And say I am reading. On making UV light of energy 6.2 electron volts incident on aluminum surface, faster photoelectrons are emitted. If the work function of aluminum surface is 4.2 electron volts, then what is the kinetic energy of these electrons? So students, here two energies are given. One is 6.2 electron volts is given, another is 4.2 electron volts is given. See here, energy 6.2 electron volts incident on aluminum surface. So this energy I am writing here E equals to incident light energy. E equals to how much is given? 6.2 electron volts. Energy is given how much? 6.2 electron volts. So when the light is incident on aluminum surface, then electrons are emitted. Then what happens? The work function of the aluminum surface is given. Work function is given how much? Work function W equals to is given as 4.2 electron volts. Energy of incident light is given 6.2 electron volts. This is energy of incident light 6.2 electron volts, and this 4.2 electron volts is what? Work function. Then what is asking? The kinetic energy is how much? So from Einstein equation I am writing kinetic energy equals to E minus W. Therefore I am writing here kinetic energy KE equals to E minus W. Kinetic energy formula what? E minus W. Here E equal to how much? 6.2 electron volts. I am writing here 6.2 electron volts, and work function is given 4.2 electron volts. Both energy and work functions are given in electron volts. So 6.2 minus 4.2 means how much? That is 2 electron volts. What is kinetic energy value here? 2 electron volts. Yes, this is the answer. But in option, see here, all options are given joules. But here what is kinetic energy? The kinetic energy value in electron volts. Options are given in joules. So to convert electron volts into joules, we require the formula 1 electron volt equal to how many joules? 1.6 into 10 power minus 19 joules. So I am writing here that equals to 2 into 1.6 into 10 power minus 19 joules. So 2 into 1.6 means how much? That is 3.2. So 3.2 into 10 power minus 19 joules. So this is the answer. In 4 options, option 4 is 3.2 into 10 power minus 19 joules. So students, problems ఈ టాపిక్లో చాలా సింపుల్గా ఉంటాయి, కాకపోతే కన్వర్జన్ అనేది చాలా ఇంపార్టెంట్. సో ఇక్కడ వెరీ ఇంపార్టెంట్ కన్వర్జన్స్, 2 కన్వర్జన్స్. One is 1 electron volt equal to 1.6 into 10 power minus 19 joules, and second conversion is very important, 1 angstrom equals to 10 power minus 10 meters. ఈ రెండిటితో పాటు you must remember Planck's constant value. What is the Planck's constant value? 6.625 into 10 power minus 34 joule second. So once again I am telling what is Einstein equation. అంటే when light is incident on a metal surface, that light consists energy, that is we are representing E. So in that energy, some energy is required to emit the electrons from metal. That energy here we are representing as work function. What is work function? It is the minimum amount of energy to emit the electrons from the metal surface. And the remaining energy, because some energy is required to emit electrons, the remaining energy is given to emitted electrons as kinetic energy. Therefore, from this operation E equals to W plus KE, where E is energy of incident light, W is work function to emit the electron, and KE kinetic energy of emitted electrons. So E equals to W plus KE. From that KE equal to E minus W. Sometimes he will not give E value and W value, he will give frequency value. Then you write energy formula in terms of frequency, E equal to H into V. Similarly, work function also you write in terms of frequency, W equals to H into V naught. What is V naught here? Threshold frequency. Frequency ఏమంటున్నాం? Threshold frequency. ఎందుకంటే it is the minimum amount of frequency. Minimum amount of frequency కాబట్టి దాన్ని ఏమంటున్నాను ఇక్కడ? Threshold frequency. So student, some problems he will give E value, W value directly. Some problems he will not give E value, W value. Instead of E and W, he will give 2 frequency values or 2 wavelength values. So 2 frequency ఇచ్చినప్పుడు థ్రెషోల్డ్ ఫ్రీక్వెన్సీ, ఇన్సిడెంట్ ఫ్రీక్వెన్సీ అనుకుంటాం. అలాగే వేవ్ లెంత్లో ఇచ్చినప్పుడు ఇన్సిడెంట్ వేవ్ లెంత్ అండ్ థ్రెషోల్డ్ వేవ్ లెంత్. Formula concept same, but you remember this conversion because in some options he will give kinetic energy in electron volts, in some problems he will give joules. So you require the conversion between joules and electron volts. What is the formula? 1 electron volt equal to 1.6 into 10 power minus 19 joules. So understand the concept, solve number of questions by using these three formulas. So in next video I will explain one more concept. Now one more question I am explaining. This question is asked in 2017. This question is also related to same topic, Einstein equation. In previous problem the question is asked kinetic energy and the data is given energy and work function. Then we used formula kinetic energy equals to E minus W. Now see here, the threshold frequency of metal is V0. When a light of frequency 4V0 is incident on metal, then the kinetic energy of emitted electrons is asking. So student, just now I explained Einstein equation. So what is Einstein equation here? Kinetic energy K equal to E minus W. So here again I am considering the same equation, kinetic energy K equals to, I am writing E, energy of incident light is directly proportional to frequency. Then I am writing E equal to what? H into Planck's constant, that is H into V. Minus work function, definition ippude cheppanu. What is work function? It is the minimum amount of energy required to emit the electrons. So ikkada work function W is directly proportional to threshold frequency V0. Ikkada energy of incident light is directly proportional to incident light frequency. Same thing, work function is directly proportional to threshold frequency. Then here I am writing W is equals to work function W equals to, here also I am writing H into V0. H into V0. So kinetic energy equal to, I am writing H into V minus H into V0. H into V0. And now I am using this formula. So kinetic energy K equals to energy minus work function, that I am writing in terms of frequency, H into V minus V0. H into V minus V0. What is V? Incident light frequency and V0 is threshold frequency. V is incident light frequency and V0 is threshold frequency. In our question, the threshold frequency of metal is given as V0. So V0 as it is I am writing V0 is equals to V0. When a light of frequency 4V0 is incident, so incident light frequency is given as 4V0. 4V0. Then is asking what? Kinetic energy. So I am writing, I am substituting the frequencies. Then kinetic energy K equals to H into incident light frequency, that is 4V0 minus V0. 4V0 minus V0 how much? 3V0 into H. So this is kinetic energy of emitted electrons. So here student, in 4 option, which option is correct? 3V0 H is the correct answer. So first I explain kinetic energy in terms of energy and work function. Next I am explaining here kinetic energy K equals to H into V minus V0. H into V minus V0. This is kinetic energy formula in terms of frequency. And you remember here one more point. What is V? Frequency of incident light. And what is V0? Threshold frequency. Sometimes they are asking theory question, when the incident frequency V is less than threshold frequency, what happens? Sometimes they are asking question, when incident frequency V is equals to threshold frequency, what happens? Sometimes they are asking question, when incident light frequency V is greater than threshold frequency, what happens? So student, in first case, what is the first case? When V less than V naught, when incident light frequency is less than threshold frequency, then no electrons will be emitted from the metal. No electrons will be emitted from the metal surface when the incident frequency is less than threshold frequency. Alage, when the incident frequency is equals to threshold frequency, then electrons will be emitted only. Electrons will be emitted only. But very important third case, when incident light frequency greater than threshold frequency, then the electrons will be emitted and the emitted electrons have some kinetic energy. So here Einstein also explained what? When energy of incident light E, when a light is incident on a metal surface, some energy is required to emit the electron, the remaining energy is given to emitted electrons as kinetic energy. So very important, this Einstein equation complete this photoemissive effect here, this from Einstein equation. So student, అర్థం చేసుకొని చాలా ప్రాబ్లమ్స్ ఉన్నాయి మన ప్రాక్టీస్ సెట్స్లో, ఆ ప్రాబ్లమ్స్ అన్నీ ప్రాక్టీస్ చేయండి. ఇక్కడ వెరీ ఇంపార్టెంట్, మీరు ఫైనల్ ఎగ్జామ్ వరకు గుర్తుంచుకోవాల్సిన కన్వర్జెన్స్, 1 electron volt equal to 1.6 into 10 power minus 19 joules, 1 angstrom equals to 10 power minus 10 meters.